Hi students, last lecture we have discussed about external morphology of the heart, parts of the external structure, and now we are going to discuss about internal structure of our heart. We know that our heart is formed from 4 chambers. Towards the broad base, 2 atria are present. And these are the 2 ventricles, those are present proximally. First, observe this figure. Internal structure of heart. We know this heart consists of these 4 chambers. Basically, 2 atria and 2 ventricles are separated by atrioventricular septum. That means septum present between atria and ventricles. These atria are thin walled, blood receiving chambers. These blood receiving chambers are again 2. One which is related with oxygenated blood, in which oxygenated blood is received, which is called as left atrium. Another atrium which is also blood receiving, which receives deoxygenated blood. Between these 2 atria also there is one septum which is internally present, so called as interatrial septum. Interatrial between 2 atria septum is present, and on the septum there is one oval depression which is called as fossa ovalis. That depression is called as fossa ovalis, which is not functional, which is nothing but the remains of foramina ovalis in the or during the embryonic condition, which may be functional, but the foramina ovalis, its remains is called as fossa ovalis, which is observed on this interatrial septum. Then, about every atria, left atrium receives blood with the help of 2 pairs of pulmonary veins. This oxygenated blood, which is received by the structure, at the same time, right atrium receives the oxygenated blood with the help of 3 vessels. One is called a superior vena cava, which collects blood from the upper region. Second is the inferior vena cava, which collects blood from the lower region. And one more, there is the coronary vein, which collects blood from the wall of the heart. In the heart, there is a rhythmic contraction and relaxation. So chances of blood backflow are more. To avoid this, muscular walls are present. With that, at the opening of inferior vena cava, there is eustachian wall. Name of that wall is eustachian wall, and the coronary veins mouth is guarded by Thebesian wall, which prevents backflow of the blood. In case of superior vena cava, there is no special wall is observed, which collect blood from the upper region. So in this way, in this chamber, blood is received from different parts of the body. We know that between atria and ventricles there is a septum called as atrioventricular septum, and the septum is not continuous, but there is a pair of apertures observed. This aperture is called as atrioventricular aperture. One aperture is present between left atrium and left ventricle, like the same between right atrium and right ventricle. With that, there is a contraction, and the forceful contraction is observed in the ventricles. So to avoid backflow, with that during contraction blood is poured into these blood vessels. At the same time, a pressure is created on these apertures to prevent backflow. Walls are present. This wall which is present between right atrium and right ventricle is called as bicuspid wall. Between the left atrium and left ventricle there is a tricuspid or mitral wall is present. To this mitral wall, these muscular fibers are connected. These muscular fibers are connected to the papillary muscles of ventricles, and these muscular wall fibers are called as chordae tendineae or columnae corneae. Columnae corneae or chordae tendineae are connected to the papillary muscles of ventricles, and those are connected to the walls, which gives additional support to this wall and prevents backflow of the blood. So there is rhythmic contraction and relaxation at the time of contraction of this atria. Blood is poured into the ventricles. Then this blood is poured into the respective blood vessels, left ventricle and right ventricle. Before that, we have discussed about ventricles. These are the blood propelling chambers that are on the blood. Pressure is created to create that pressure. Walls of the ventricles are thick, and from this again left ventricle wall is more thick, which is 3 times more thick as compared to the right ventricular wall. And this wall which is formed from cardiac muscles. Inside this ventricles, small chambers are fissures are observed due to the presence of these columnar muscular fissures, which increases area for the blood. So in this way, these 4 chambers are related with different activities. That is receiving the pure blood, oxygenated blood, receiving the deoxygenated blood, propelling the oxygenated blood, propelling the deoxygenated blood. Then from this ventricle, from the base of this ventricle, there is an arisal of aorta takes place when there is relaxation of the ventricles. Backflow from the aorta or pulmonary tract may take place. To avoid that, 3 cup-shaped structures are present. These are called as semilunar walls. These semilunar walls prevent backflow after the contraction and at the time of relaxation of the ventricles. This aorta carries oxygenated blood from the left ventricle, while the pulmonary artery which carries deoxygenated blood towards the lungs for the oxygenation. So these are the different parts of the heart and their functions in short. Then we are going to discuss about the pumping action of the heart. Pumping action of the heart, which is nothing but a rhythmic process in which contraction and relaxation takes place. Contraction is called as systole and relaxation is called diastole. One heartbeat includes 1 systole and 1 diastole, in which systole of atria, which is continued into the ventricles, and ventricle contracts. Like that, after completion of atria, atrial contraction, ventricular contraction takes place. Then again, atrial relaxation, then ventricular relaxation. That means these events are occurring one after the other, so called as rhythmic process. One heartbeat includes 1 systole and 1 diastole, and 1 systole diastole forms 1 heartbeat. In human being, at about 70 to 72 times heart beats per minute. That is the beating rate per heartbeat at the time of ventricular systole. About 70 ml of blood is released or poured into this structure, that is aorta. That 70 ml of blood is nothing but stroke volume per heartbeat, means 70 ml of blood, that is the stroke volume, into 72 heartbeats per minute. About 5,000 ml of blood which is given out per minute by the heart, which is called as cardiac output. Is it clear? Pumping action, which is related with contraction relaxation, which is rhythmic process. One contraction, one relaxation, or one systole and one diastole forms one heartbeat. Per heartbeat, about 70 ml of blood is poured into the blood vessel, which is called as stroke volume, and per minute about 5,000 ml of blood is given out, which is called as cardiac output, that is per minute. Then about conducting system of the heart. Human heart, which is well developed, which is myogenic, special term, myogenic heart. In the higher organisms, heart in which wave of contraction initiated from the single point, which is situated in the right corner of right atrium at the base of superior vena cava, which is called as SA node or nodal tissue. Conducting system initiated from this point, which is situated at the base of superior vena cava, which is called as SA node. So rhythm of contraction initiated from this point, so called as pacemaker. This structure is called as pacemaker. In the heart, about 4 types of nodal tissues or special type of conducting tissues are present. This conducting tissue helps in the carrying fast stimulation of contraction over the wall of heart. So first is the sinoatrial node. When it contracts, your contraction carried over the wall of atrium, and one reaches to the another nodal tissue point, which is situated at the base of right atrium near the interatrial septum, which is called as AV node, atrioventricular node, which is stimulated and the wave of contraction carried through this special type of conducting tissue, which is present in the wall of ventricles, which is called as Purkinje fibers. This Purkinje fibers gives out branches, secondary and tertiary branches, and the branches are called as bundle of hits. This bundle of hits and Purkinje fibers send message of stimulation or helps in the contraction of wall of ventricles. In this way, conducting system activates and which carries wave of contraction, or that impulse is carried with the help of these 4 tissues is the SA node, AV node, Purkinje fibers, bundle of hits, which helps in this process, that is the conduction of wave or wave conduction in the wall. Then we will discuss about cardiac cycle is a part of working mechanism we discuss about the working. Before this, we have discussed about one heartbeat. One heartbeat means one contraction and one relaxation, which forms one heartbeat. This contraction relaxation also called as systole and diastole. For the completion of one heartbeat, 0.8 seconds are required. The first atrial contraction takes place. Atrial contraction, wave of contraction initiated from the SA node reaches all over the atrial wall, which requires 0.1 second. Then AV node is stimulated, and this AV node carries, AV node means atrioventricular node, which carries wave of contraction over the ventricular wall, and for the contraction of ventricle 0.3 seconds are required. When there is a contraction of ventricle, atrial contraction which is stopped and atrium at relaxation stage. After the contraction of ventricle also relaxes, and after that both chambers are at relaxation stage, which is called as joint diastole, which requires 0.4 seconds. In this way, it is called as one heartbeat completed in 0.8 seconds. So we will discuss one by one about this cardiac cycle, means events related with contraction and relaxation of the chambers of the heart, and time required for these events for the completion of this cycle, that is cardiac cycle. We will discuss one by one about atrial contraction, ventricular contraction and joint diastole. So we will stop here. Thank you.